So in chapter 7, we're going to do something called linear programming. And it sounds scary, but really it's just graphing with inequalities. So we're going to do a quick review for how to graph lines and how to graph inequalities. And then we'll dive in and start talking about feasible regions and all that kind of good stuff. So first thing we want to do is look at two different ways that we could graph a line. Okay, there's actually more than two ways, but we're going to find two easier ways. So one is to get your line in a format of y equals mx plus b. So first thing to notice, the exponent on the x is a 1, and the exponent on the y is a 1. So that tells me that this is linear. Okay, it makes a straight line. Remember, in math, all lines are straight. The other way that we're going to do this is using intercepts. So we want standard form. So I'll have ax plus by equals c, and notice that I've got my x's and then my y's and then my c. Okay, so that should look familiar from the last section when we were doing systems. So you're thinking, but wait, these are equations, they're not inequalities. I understand that, but we're going to start off by just remembering how to graph a line. So worst case scenario is you could always make a chart of x's and y's and just randomly grab some x's and shove them into your equation and then see what y's they pop out. Okay, and you can do that on either one. You'll just have to do a little bit of math on this side. So this is like the least favorable one. But let's go through this thing and look at this. All right, so if I have y equals 3x plus 1. Okay, the number by itself, the constant, tells me where it hits the y-axis. So if I graph this, this hits the y-axis at 1. So I immediately know that that point right there is a point that I'm interested in. So if it was -7, if it was 3x minus 7, I would plot at -7 way down here. Okay, this number, which is the coefficient, will tell me the slope. And I always want that to be a fraction. So remember, I can write anything over 1. The reason we want it to be a fraction is the top number will tell you up or down. If it's positive, you go up. If it's negative, you go down. And the bottom number will tell you right. Okay, the bottom number tells you right. So I'm going to go up 3, right 1. So I'm going to go 1, 2, 3, and then right 1 unit. And then I have my lovely little line right here. So this is the graph of y equals 3x plus 1. Okay, now remember that there's an infinite number of points on the graph. Okay, so if there's an infinite number of points, we only needed 2 to define the line. But once we define the line, there's an infinite number of points on that graph. Now, go back to slope for just a second. I told you that the top number is up and the bottom number is right. You can also reverse that. Okay, so you could say go down 3, left 1. So if I were to go 1, 2, 3, and then left 1, I'll find my graph again. Okay, so I just use the up or down and then right. I use that to find my next point, and then from there I can just follow the pattern because it's not going to deviate off that line. Now, come over here for standard form. If I have something like 3x plus 2y equals 6. Okay, so this is standard form. Now, the first thing I notice is that 3 is a factor of 6, and 2 is a factor of 6. And that's going to make my life really easy because all I have to do is say, what happens if this term wasn't here? In other words, what happens if x is 0? So 0 times 3. If x is 0, then what would y be? Well, 2 times what is 6? 2 times 3 is 6. Okay, so I covered up this one because I zeroed it out, and then I solved this one. Now, do the backwards part. What happens if y is 0? Well, 0 times 2 is 0. So now look at this part. And I have 3x equals 6. Well, 3 times what number is 6? So I zeroed out my y. So my y coordinate is 0. And then 3 times what is 6? 3 times 2 is 6. Now, it's not always going to be that pretty, which is why we may need to come back to this side. But in this case, it was pretty. Do not just think that you can flip-flop these numbers. It will not always work that way. I just happen to choose it that way. And then how many points do we need to make a line? I need 2 points. Guess how many I have? I have 2. So I will not go left or right, but I will go up 3. So here's that one. I will go right 2, so 1, 2, and I will not go up or down. And then I have this is the equation, or sorry, the graph of that line. Okay, so now let's introduce some inequalities. So that's your basic thing. We're going to practice this more as we go through. But let's look at some inequalities. If I have less than, or if I have greater than. Okay, the way I'm going to graph this is I'm going to use a dotted line. Or a dashed line, whichever. It doesn't matter because you're only going to be given one of those two options. Okay, it's either going to be dotted or it's going to be dashed. What it means is that line itself is not included, but everything on either side of it is. Okay, if I have less than or equal to, greater than or equal to, it's going to be a solid line like what we're used to dealing with. So I'll have a solid line. Now, how do I know which side to shade? Because you remember with inequalities, there is a load of answers. Okay, so what you're going to do is either grab a test point. All right, so for shading, we are either going to grab a test point and see if it works in the equation. If it doesn't work, then we'll have to go on the other side of the line. So let's just pretend like I need to shade on this one, which I don't because it's not an inequality. We're pretending. I would grab something over here. So like I could grab 10, 0. Okay, and I would test it in this equation up here. If it works, then I would know I need to shade on that side. If it doesn't work, I would know I need to shade on this side. Okay, so that's one way to do it. The other way to do it, and that's going to be if it's set up like this, is which side is y bigger than or which side is y smaller than. So this is more straightforward. This is going to need a little bit of work. And I know it kind of sounds weird right now. Just remember that we're going to practice in a few minutes. The last thing that we're going to do, hang on, I can't remember the last thing we're going to do. Oh, vertical and horizontal. All right, so if I have a vertical line will be of the format x equals some number. Okay, that will be a vertical line. How do I remember that? Because you're thinking, but wait, the axis is a horizontal axis. If I graph this axis, that's my x-axis and that's my y-axis. What this says is I slice through the x-axis at this number. Well, the only way to slice through the x-axis is to just like grab vertical. If your choices are vertical or horizontal, okay? So I would slice through, which means it's going to be vertical. So let's pretend for a second that I've got x equals -2. Then this would be the graph of my line, okay? And then look at the coordinates that you've got. This is going to be -2, 0. This is going to be -2, 1. This is going to be -2, 2. This is going to be -2, -1, -2, -2. So what it's saying is all of my x's are -2. My y's can be anything, but all of my x's are -2. Now, remember that your exponent is a 1, and there's only x's. And then we're going to fine-tune this thing in a second. So what happens if I have y equals some number? Remember, there's no x. Okay, so if I'm looking at just the red thing, it says y equals a number. Then y equals, well, let's pick something. Let's say y equals 3. That means I slice through the y-axis at 3. Okay, so let's look at the options that we have. So if I have y equals 3, this point is 0, 3. This is 1, 3, 2, 3, 3, 3, 4, 3. Okay, so all of my y's are 3. X can be anything it wants to, but all of my y's are 3. So x is a vertical line, y is a horizontal line. And remember, it's just one or the other. So let's look at this. If I have just x's, it's vertical. If I have just y's, it's horizontal. If I have x's and y's, it's going to be diagonal. Okay, so there's your summary. Just x's is vertical. Just y's is horizontal. And x's and y's will be diagonal, which we could also say is slant or oblique. Oblique is the big word. Oblique. Okay, fancy way of saying it's diagonal. All right, so that being said, that is our intro. So we're going to go through and we're going to graph some of these things. So, and what I'm going to do is I'm going to share my screen on the video so that you can see exactly what we're doing. All right, so that is this video.